Root4j could neither take root files independently as input from the user, nor display the information stored in it. A lot of the code to iterate over the T-trees in the root files was written in SparkRoot, as well as the code to generate the output from the root files. SparkRoot takes the files as input from the user and reads it using the root file reader present in Root4j. Then SparkRoot uses the data types created in Root4j to iterate over the branches of the T-tree present in the root file. The goal of the project is Root4j should ultimately be a standalone application which should be able to both read and display the contents of all root files without having to depend on external libraries to do so. And Root4j should completely be just a Java-based root reader, and SparkRoot should only contain the Spark interface and not code to actually iterate over the T-trees and then display them. Root4j should ultimately work entirely on the Java virtual machine, so it should be accessible as a dependency for all Java products to be used as a medium to read root files. SparkRoot should ultimately import Root4j as a dependency, where all the main work of iterating over the branches and then displaying the output should be done by Root4j. So the work which I did for implementing it was moving the T-tree iterating code from SparkRoot to Root4j by translating the code written in Scala to Java. I wrote a class in Root4j to display the contents of the root file, depending on the contents. And currently Root4j cannot directly take the files as input from the user, but I was currently working on it. When the HDFS implementation of Root4j to read the files is complete, it should be able to directly iterate over all the branches of the T-tree and print out the results, depending on the based on the code which I wrote. Since in the previous version of SparkRoot, Spark was being linked to Hadoop to take the file as input from the user, I decided to try and do the file reading from the system using HDFS because I felt that that would be an easier way of doing it. HDFS of the Hadoop distributed file system provides high performance access to data across Hadoop clusters, which would be a good way to read the files. So the utility of reading root files via the JVM is that now that we can read the root files solely on the JVM, we can now use other software based on the JVM to analyze the registered data. Some big data analytics software includes Hadoop, Apache HBase, and Apache Spark. The final functionality which should be present in SparkRoot would be to remove all the root iterating code from it and just contain the code to read the abstractly typed tree generated in the newer version of Root4j, and to convert that data types into a Spark readable format, we should ultimately create a schema to convert the root data into rows and columns which can be displayed via Spark. So we have thought of a test case where a software working via the JVM could import Root4j as a dependency to check if the separation was perfectly maintained. A nuclear physics group at Jefferson Lab has developed root-like visualizations in Java by developing a software called GRoot. GRoot is a Java data visualization project designed to make histogramming, plotting, and fitting accessible to all Java users. We can test if all the functionality has been ported by importing Root4j as a dependency to GRoot and seeing if SparkRoot and GRoot can read the same files. Currently, we cannot test this since I have not yet completed the HDFS implementation in Root4j, but it should work ultimately when it is complete. This is an example of some output generated by GRoot. The pictures have been taken from the GitHub page of GRoot, and these are just some sample graphs for some randomly generated function. So the work which is left to be done is, since I've already started trying to get the Hadoop distributed file system working with the newer version of Root4j, there are three things which needs to be done still, which is completing the HDFS implementation and testing out the functionality of the code, making sure that Root4j does not have to ultimately rely on HDFS, because we want that Root4j should directly take the local files as input from the user and not first uploading it to HDFS and then calling it from there. And we should have to remove all the translated code to remove from SparkRoot, so that there is no code duplicacy between SparkRoot and Root4j. Yeah, so that's about it. Thank you.
Great. Thank you. Are there questions? Yeah, I think this stuff looks great. I'm curious. It's sort of a meta question, but for these student projects, kind of what the happens from here in the timeline. Does that make any sense?
Mm-hmm. So both of these two student projects that we'll be talking, we don't have very much time left, something on the order of a week. So with this one in particular, so I'm not sure if the status was entirely clear, but what Pratyush was talking about at the end was the test that would demonstrate that the refactoring has been complete. We're not there yet. It's not working just yet. But if Pratyush doesn't finish before he starts classes in I think under a week, Victor is still available to finish this up, clean it up, and before he starts his new job.
Okay, yeah, that's great because this is definitely nice progress. It's also a nice example, I think, of what the kind of thing we're trying to see with Diana in terms of bridging the sort of industry standards and route. It looks really nice.
Yeah, could you tell me a little bit about where you are with the HDFS integration? I mean, are you stuck? Do you need help? How are things?
Currently, since I had no experience with HDFS, I just started trying to implement it last week. But I got stuck in the National Chess Championships for 3 days, so I haven't really been able to work too much on it. But as of now, I am trying to get the file read by HDFS, but from HDFS, but I'm getting some error on the while compiling, something along the lines of class definition not found or something.
Okay. And since this is a Java project, that's likely a dependency that needs to be added to the Maven POM file. Okay. Something to include the HDFS file system as a dependency. Let me make sure. When you just before you left for the competition, you were trying to get a local installation of HDFS working, so that you would have something to test. It sounds like that is working now, right?
Yeah.
Okay.
I've uploaded the file to the HDFS and I can see it, but I cannot directly load it into the program, which is where I'm stuck.
Right.
Actually, this is maybe a question more for Jim, but is a piece of Root4j what confirms the sort of physics validation as these changes get made? Are there unit tests that are showing that translation is always working?
I think that there weren't unit tests because it had been intrinsically bound to Spark, and including Spark in the loop of a unit test would be pretty difficult. Yes. But when the factorization is complete and we can read root files in Root4j, then we can talk about being able to write a suite of tests that are based on just some root files in the local directory, and it should just be able to read them and verify that the contents are as expected. The combined project Root4j plus Spark roots has in the past been reading meaningful results out of root files as complex as CMS AOD, actually computing ZPeak plots and such. But that's an integration test and not a unit test.
I didn't mean a specific implementation, but right, that's a sort of test that's really nice to go back and do. Sounds like that's in the plan, so that's great.
Right, but just know that we're standing on something that has been proven to make mass plots correctly, so it is it must be mostly right. But now that we'll have this simpler interface to it, we'll be able to write unit tests.
Yeah. So I would sort of suggest maybe we go to the next talk, but I'd also like to kind of just bookmark one quick thought, which is that came up, is that there's, there's a CMS Open Data project and things like this, and the CERN Open Data project more generally, and there they have actually quite a few, software types that are working on the Open Data project. Most of that is about the infrastructure for actually serving up the files and things like that. But one of the sticky points of all of that is basically root dependencies and software dependencies and things. So we may actually, I bet they would be interested in this, and we may be able to even team up with them and see if we can get some of, because they have quite a few people that are employed working on this kind of stuff, to try to help out a little bit with some of this sort of lighter weight root I/O. Just something maybe we should try to remember. Yeah,
we should do that.
So Kyle, specifically, who is it? We should. I mean, it boils down to putting some set of people in contact and.
Right. Yeah. So Sunyi and Tibor are the 2 point people to talk to. But I'll send a quick email with just names to try to bookmark that idea.
Okay.
Great. Thanks.
Okay. Any other questions? Okay, so let's try to share the screen at CERN and go to the next talk. Let me see if I manage. I do. Okay. Okay, I should be sharing. Can someone confirm? It's like I was.
I see it. Good.
Okay, great. Okay, so Sanat will give us the second talk on his investigation of a query system framework for HEP.
Okay, ladies and gentlemen, my name is Thanat Jatupatrachat. I'm currently a student in computer engineering in Chulalongkorn University and also a summer student at CERN. And my topic today is the investigation in query system framework for high energy physics, mostly about the query engine for distributed system. So, before we dive into the talk today, I would like to give some overview of the talk today. So I will start with some problem and the background of the project, and then I would like to show how can we distribute query in the system, and then I would like to show how should the system server serve this distributed query system, followed by the third-party framework that I have been investigated in. And also, to make it clear, I would like to show the design, use this third-party framework to, and show how can it be fit into the system here. And last but not least, just a bit of conclusion and future work. So let's start with the problem here. So our team's the main objective is to create a femto code, which is the query language that can provide the ability to make plots or other aggregations directly from the collaborations analysis object data in real time. So to make this more robust and be able to process much more data, it is important for us to deploy this into the server, like redundant commodity distributed server. So the key is that we need something to simplify the distributed application, whether it is the cluster resource management or something that the coordinator that can keep track of the job in the system. So here's how the query should be distributed in the system. So once the query comes in, we can divide it into the smaller pieces identified by the dataset and group ID. And with these smaller pieces, we can distribute this to over the compute node. Every node can get that data and calculate the data, and then return some partial result to the client. So that is the key idea. So how is the third-party framework that I have been investigating? Well, there's 3 main frameworks that I investigate all over this summer. The first one with the lovely name on the left is Apache Zookeeper. So the Zookeeper is allow us to distribute that application to coordinate with each other through a shared hierarchical namespace. So I will show it later in this presentation. The next one is Mesos. Mesos is said to be a distributed system kernel. So in other words, it makes the redundant commodity cluster to be one big computer. So it's easier for the programmer to program a distributed application. And the last one here is Marathon. Marathon is the container orchestration tool. So the main point of using Marathon here is to launch the application, whether it is container or not, and launch it in our cluster, and Marathon will handle the rest, whether it is how to scale, how to heal from the damage that we get. So, but for the scope of this summer, the proof of concept here, I use only Apache Zookeeper for the current work. So the key point is to use Zookeeper as the coordinator of the system. I would like to use this to keep track of the query, which is divided into the smaller pieces, so that the compute node can know and can communicate with each other how to divide this work in the cluster. So why Zookeeper then? As mentioned before, Zookeeper file system is a hierarchical file system like a Linux file system, and is able to be accessed from any cluster, any client in the computer cluster here. And for Zookeeper, it is designed to be fast for reading and writing. For reading here, client, which is anyone who connect to Zookeeper, can read from any of Zookeeper server here and get the same result. For writing to the Zookeeper cluster here, client can also write to any cluster, but every write will be propagated to the leader of the Zookeeper, and then the leader again will issue the write to other followers of Zookeeper. So although it's fast for read and write, but read is faster with this reason. And also Zookeeper also gives us the guarantees on these 5 topics. The first one is timeliness. So the update, the client will see the update like in the specific time bound. So it is guaranteed to be the most up-to-date one. And the next one is sequential consistency. Here, the update from the client will be applied in order. This is guaranteed by Zookeeper. And the atomicity, which is the guarantee that the update is with either errors or success. That's all, no partial result. And the single system image, as mentioned before, the client can read from any Zookeeper server, so it will get the same result no matter where it reads from. And the reliability here that Zookeeper gives us is once the data is updated in the server, it will be persist. And it will be there until it is overwritten with the next update. So how can I use Zookeeper here in the system and come out with this query system layout? So this is the design that I use to test this third-party framework. Let's start with the client here. Client is where the user connect to. So with Femto code, when user write the code here and connect to the client, client will submit the job to our server, which is the dispatch here in the diagram. So the dispatch will decide whether it should put the new job in the coordinator or not, so that other compute node could execute the job. And if the answer is yes, dispatch will put the job in the coordinator. So right now, the job status will be in the part like the picture on the top right. It could be stored like the owned job, the unowned job, so that the compute node can come to the Zookeeper and ask, is there anything to do? Is there anything to compute right now? And also we can keep track on that. with the dataset and group ID that is mentioned in the diagram before. Here, the job will be unique using this dataset and group ID. So right now, it's good enough for a computer to access the shared storage here. So computer will go to Zookeeper and get some unowned job to compute. Then the compute node here can compute the job using the cache in the local machine that in that computer cluster. Or if the cache is not there in the compute node, it can wait for the other compute node with the cache to get the job. But if nobody get that, it will fetch the job, it will own that job, and go to fetch the data from certain database, and then execute the job. When it finishes executing, it will store the partial result in the storage, where in here we use MongoDB. And that also the compute node have to update the status of the job in the coordinator as well. In this way, when the job is successfully done, the dispatch will know from the Zookeeper that, okay, the job is done. So now I can get that partial result from the MongoDB and return that to the client. And also next time, if there is any queries with the same dataset and group ID, then dispatch doesn't have to put the job in coordinator, but instead it can fetch the data from the MongoDB here, which is our storage. So this way we can do the job faster. So for the result from the design here, I divided the implementation into 3 phases here. The first one is the development in my local machine laptop. So I use the threading to simulate the distributed programming and to prove of that concept. After that, I moved to use the CERN OpenStack private cloud to actually launch an instance to test the high availability and also the distributed query. And I'm now currently in this state. And lastly, for my future plan, I want to deploy this system in the cluster with the Marathon install. That is the Padua cluster facility for me. So in this way, we can actually launch as many as like a container and instance as we want using the Marathon. So I can test the system at large scale in this way. So here's some example for my local machine here. If you remember from the diagram, when dispatch want to put the job into Zookeeper, you can see in the highlight rectangle here, it will create the entry in that unowned path. That means a new job that nobody owned yet, so somebody needs to finish this job. So after that, this job, when it is in Zookeeper in the unowned path, then the compute node can like regularly come to Zookeeper here and fetch the job. So when it gets the unknown job, it has to delete that to the unknown path and put that into the own path instead. So other compute node will not do the exact same job again. So somebody owns that, nobody should interfere. That is the idea. And when that compute node finish doing this, it should put the job in the done path. So in this way, the dispatcher could know, well, this job is finished. So it could go to the database and get the result and return this to the client. And that is the key idea of how it works in this system. So all in all, for the conclusion here is that for my investigation and my the example project, methods in Marathon might be good when we want to build the application at the scale. Zookeeper at that time can also be used as part of Mesos high availability also, and also can be used as a shared storage coordinator as well. But as of now, only Zookeeper is enough to satisfy the design as a job coordinator for the computing cluster as well. And here's my future work. If I have more time to implement this, I would like to test the system on the cluster using Marathon and Docker, and also want to test the performance of the system scalability at large scale, really large one. And if possible, I would like to integrate this query engine. My work is in the distributed work part, so if it's possible to integrate with the language part, it would be perfect. And last but not least, I would like to design the MongoDB charting so that we can store a large scale of data in Mongo by equally distributed jobs into many clusters. And that is all my work. Thank you.
Thank you. Question? Thought? There's at least noise outside, so I know we're connected. Great, thanks again. It's very good. Are there other topics for today's meeting we should cover? That was our agenda.
Did you ask about questions for this talk?
I tried to. Let me ask you again.
Okay.
Are there questions for this talk? Sorry again. Not
Hey,
heard.
sorry, I had a question, but I couldn't find the mute button, or unmute button, rather. So, in terms of scaling up, it seems Zookeeper is a essential service, and I mean, I guess I was just thinking of existing computing resources that we have. Kind of the Mesos Marathon Zookeeper stack is pretty foreign and might be hard to put together. Is there a way to do it without Marathon?
So you mean the way to use it without Marathon, right?
Yeah.
Yeah. As of now, I implement the system without Marathon. So I use a pure Zookeeper here as a coordinator of the system. So it's possible without Marathon, but it will be also difficult when we want to deploy with Marathon as well.
Brian,
This might be the right audience to ask.
Go ahead, Jim.
This might be the right audience to ask this question. We were just talking about this morning. Marathon will let us, launch Docker containers on a system. We were wondering. I've heard that HT Condor can launch Docker images and to integrate with existing stacks. That might be the way to go. Any comments on that? HT Condor for running indefinite, daemons that run forever.
Yeah, I mean that's kind of why I was asking was, again, kind of thinking if we wanted to run this at Nebraska, what would it look like since we're a big Docker site, but we run it on top of HT Condor.
Well, great.
I mean, for actual permanent stuff, we would probably do we have a small Kubernetes cluster, and that's kind of the vertical stack we've been leaning toward. But for capacity, bringing capacity up and down, kind of the parts that you want to horizontally scale, that would definitely have to go on Condor. At least the current site configuration. But doing something that's a one-off, like adding a single Zookeeper service, that's not so bad. But I was just trying to think of how this would play out locally.
Well, Zookeeper might run in a container, and you always have at least 3 of them.
Well, yeah, but just in terms of something that has to be monitored and cared for and fed and things like that. That seems to be like the big thing, and that's a finite thing too.
Yeah. maybe I can provide a bit more context too. This project was a search through existing services space for something that can solve our problem. And we spent a lot of time looking at, Tanat spent a lot of time looking at Mesos and then Marathon, and then wandering through the space, we were finding that these are not really good for submitting queries. They're good for submitting long-running jobs. Wandering through the space, we found that Zookeeper was essential to one part of something, and then discovered that it solves a lot of these problems, as he's described how exactly we can use Zookeeper. So currently, it sounds like this would be an essential part of the stack.
Yeah, this or something like it. We hadn't found other alternatives other than, you can, of course, can write your own, but that didn't make sense, or doesn't make sense.
And kind of the spirit of this project was finding ways to not write our own. Before this summer, I was assuming that all of this had to be custom built. Other questions?
Okay, sounds like not. Any other business then for today? Okay, very good. I think the next Diana meeting is probably the first week of September, if I remember correctly. So thanks again for coming, everyone.
Bye.
All right, bye.
Bye.
Bye-bye.